Hello, my name is Professor Blackman, and today we're going to be talking about Unit 1, Lesson 1, which is solving equations. We're going to start out about talking about what a solution is, which eventually becomes checking a solution after you solve it, and then we'll do some problems with solving linear equations using the addition principle and multiplication principle. I have some important definition right here where it's talking about the solution of an equation is where the replacements of the variable that make an equation true are called the solution of that equation. The set of all solutions is called the solution set of the equation. When we find all the solutions, we can say that that equation is now solved. So let's go ahead and get started on our first examples. All right, so here we have a problem given to us as x equals 17, where x plus 24 equals 41. So we're trying to determine if this x here is a solution to this equation that is given here. So I like to start out by looking at x plus 24 equals 41. Now what we want to do is take this x and plug it in right there. So now I have 17 plus 24 equals 41. And then I'm going to add this together. 24 plus 10 is 34, plus 7 is 41. So you can see here that the left side is 41, right side is 41, so we can say this does equal this, so this is a solution. So we can just answer it and say, yes, it is a solution. Over here, we're going to do the same exact thing. We're going to take the 4 plus 5, and I'm going to take this negative 11 and plug it right in there for that y. So this what used to be 5y is now 5 times negative 11. Okay, 4 plus 5 times negative 11, we need to do multiplication first, so this would be negative 55 right here. So we have 4 plus that. And 4 plus a negative 55 would be a negative 51. And so negative 51 does not equal 59, so this is not a solution. So if you're ever working through a problem and you go to check your solution and you end up having the left side equal the right side, you could have either made a mistake when you were solving that problem, or it's just not the correct answer. All right, so now let's do some that involve solving. So what we need to do is we need to apply the addition principles. So the addition principle basically says if A equals B and you add C, which is the same to both sides, then you end up with A plus C equaling B plus C. Let's do this as like a basic example. Let's say you have 1 plus 1 equals 2. Everyone agrees to that. Well, if you add 3 to both sides, so now you have 1 plus 1 plus 3. And on this side, I'm going to also add 3, so we have 2 plus 3. So I have 1 plus 1 plus 3, that's 5. And 2 plus 3 equals 5. So if you start out with two things that are equal to each other, you add the same thing to both sides, then those two sides will remain equal to each other. That's basically what the addition principle is stating. And it also works for subtraction, because subtraction is the opposite inverse of addition. So here I have y plus 6 equals 13. I want to get this y by itself, so I'm going to subtract 6 from both sides. And now I'm going to simplify that. 6 minus 6, that's gone. This gives me y equals 13 minus 6 is 7. Now, after working it, I want to check, just like how we did it before, I want to check my solution. So y is now 7. So 7 plus 6 needs to equal 13. 7 plus 6 does, in fact, equal 13. So the left side equals the right side when y equals 7. So I know that that is correct. All right, now let's go ahead and look at our next example. We need to figure out what x is here to make the left side equal the right side. Well, this is negative 3/8, so I need to get rid of this negative 3/8. So I'm going to add 3/8 to both sides. Now over here, I also need to add 3/8 because with the addition principle, whatever you add to one side, you got to add to the other side. But this is a 24, and I don't need to add 3/8 to that because the only way to add fractions is your denominator has to be the same. So I'm going to just kind of create a little like thinking box here. If I have 3/8, but I need that to become a 24 on bottom. The only way 8 becomes 24 is times 3. So 3 times 3 gives me 9. So here, if I'm adding 3/8 to the left side, I'm going to add 9 24ths to this side. Now that's the same thing because 3/8 and 9 24ths are equivalent. So I'm adding the same thing to both sides, even though they look different, because 3 times 3 is 9, 8 times 24, 8 times 3 is 24. So you get the same thing. So now when I simplify both sides, negative 3/8 and 3/8 gone. Left side is just x. On the right side, negative 5 24ths plus 9 24ths. 9 minus 5 gives you 4 24ths. Now, 4 24ths, those are both even numbers, so I know it can simplify. They're also both multiples of 4, so this will equal 1/6. So we could go ahead and check that as well. So negative 3/8, that's part of the checking process. Negative 3/8 plus 1/6 needs to equal negative 5 over 24. Well, negative 3 over 8 and 1 over 6, we can't add those together until they're both multiples of 24. So this is times 3, and this is times 4. And as you see, negative 3 times 3, negative 9. 1 times 4 is 4. So negative 9 and 4 give you negative 5 over 24, which is the same as negative 5 over 24. These two equal each other, so I know that 1/6 is my solution. All right, now let's look at one where we use the multiplication principle. So just like before, if you have two values that equal each other and you multiply the same thing to both sides, same non-zero, because if you multiply 0 to both sides, then they equal each other no matter what. So we always need to multiply a non-zero number. So let's say you had 2 equals, and I'll use the same thing, 1 plus 1. If I triple this side and I triple this side, 3 times 2 is 6. And tripling 1 and tripling 1 is 3 plus 3. You can see that 6 clearly does equal 6. So as long as you multiply or multiply by a fraction, which is dividing, very similar, is the same as dividing, you get the same equivalent thing. So 3x equals 18. I don't need 3 of something. I need just x. So I'm going to divide both sides by 3, and you get x equals 6. And that's a pretty fast one you can check. I'm pretty sure most people can just check that in their head. 3 times 6 needs to equal 18, and it does in fact equal 18. So that is correct. All right, let's look at our next one. 3/2 of x equals negative 1/4. Now on this one, I want to multiply by its reciprocal. So the reciprocal of 3 over 2. What I need to do is I need to get rid of this 2 on bottom, which means I need to multiply. And I need to get rid of this 3 on top, which means I need to divide. So you can just multiply by the reciprocal, which is just flipping this fraction. So over here, I'm going to multiply by 2/3. So then I have 3. I need to start canceling things out. And this 2 cancels this 2, this 3 cancels this 3, and you get x. Negative times positive is negative. This 2 and this 4 are multiples of 2, so they can cancel each other out, because this is 2 times 1, this is 2 times 2, so you can take out a 2 of both of those, and now you have 1 here and 2 here. So on top, I have 1 times 1, which is 1, and on bottom I have 2 times 3, which is 6. So I would like to check that, because I always like to check my solutions. It also does say it in the directions. You should check it. And so I'm going to do 3 over 2 times what my new x is, which is negative 1/6. And that it needs to equal negative 1/4. Positive times negative is negative. 3 and 6 both have multiples of 3, so that's a 1 here and a 2 here, because 3 times 1 and 3 times 2, canceling out those 3's. On top I have a 1. On bottom I have 2 times 2, which is 4. So I have negative 1/4 equaling negative 1/4. So the left side does equal the right side when x is negative 1/6. All right, so now here's some steps that I have found useful for students who are solving linear equations. You can go ahead and pause the video and write that down if you would like. Basically, for me, I always consider solving get your x to one side, everything else to the other side. If there's any time you can simplify, simplify before starting. So here on this side, we have 3x and negative 7. So one's a variable, one's a number. Over here, we have a number and variable. So I want to combine these two before we get started. So I have 3x minus 7 equals negative 7. A negative 4x and a negative x is a negative 5x. So here, now I want to get my x's to one side. So I'm going to add 5x to both sides. Add 5x to both sides. And that gives me 8x minus 7 equals negative 7. Now I need to move the numbers over to get this variable term by itself. So I'm going to add 7. And so now I have 8x equals 0. Well, the only way to get 0 is to multiply by 0. So when you divide by 8 here, you get x equals 0. 0 is one that you should have no problem plugging in to your solution because it's just 0. So 3 times 0 is 0, minus 7, negative 7, minus 0, 4 times 0 is 0, minus 0. So you have negative 7 equals negative 7. If you ever get 0 as a solution, you should be able to check that completely in your head. All right, so let's look at this next one. I have a 6/5 x, a 4/10 x, and a 32 over 10 here. Well, I need to combine these x's together, but I can't add fractions unless they have the same denominator. So I'm going to multiply this denominator and this numerator by 2. So 6 times 2 is 12. 5 times 2 is 10. So now I have 12/10 x plus 4/10 x equals 32 over 10. Add those up. 12 plus 4 is 16 over 10. X equals 32 over 10. And we can simplify this here, but I just would rather just go ahead and multiply by the reciprocal. 10 over 16. Multiply by 10 over 16. 16 cancels 16. 10 cancels 10. You're left with just x equals, cancel 10s, 32 divided by 16. Well, that's 2 here and a 1 there. 16 times 1, 16 times 2. So this equals 2. We can go ahead and check that. If I put a 2 in for my x, I get 6 over 5 times 2 plus 4 over 10 times 2 needs to equal 32 over 10. So 6 times 2 is 12 over 5 But since these are over 10, I'm going to make this over 10 as well. So 12 over 5 would become 24 over 10. 4 times 2 is 8 over 10 equals 32 over 10. And then you can see 24 plus 8 gives you 32. All 10s on bottom. So I know that that is correct. All right, let's go ahead and look at one that now have parentheses in them. So we need to use the distributive property. If you forgot the distributive property, I will go ahead and write it up here at the top. A times B plus C is equal to A times B plus A times C. So whenever you have a number or term outside the parenthesis, you need to distribute to everything inside that parenthesis. So I'm going to distribute this to here and this to here. And I'm going to take this negative and distribute here and there. So I now get 21x plus 7 times 6, 42, equals 11. I'm just going to bring down. So this minus x plus 2, so that's a positive x plus 2. When you apply a negative to that by multiplying it, it just changes the sign. So that's negative x. X becomes negative x, and positive 2 becomes negative 2. And here I have a number and a number, so I'm going to combine like terms. So I get 21x plus 42 equals 9 minus x. And now I want to get my x's to one side, so I'm going to add x here, add x. And I need to move my numbers over, so I'm going to subtract 42, and 21 plus x would be 22x. And over here, these x's are going to cancel out, and I have 9 minus 42, which is going to give me negative 33. I need to get rid of this 22, so that's 22 times x, so I'm going to divide both sides by 22. And x equals, I have a negative divided by a positive, which is a negative, and then these are multiples of 11, so that's 3 over 2. All right, let's go ahead and look at our next one here. And I'm going to distribute that 2/3 to everything. So 2 times 7 is 14. And 3 times 8 is 24. Plus, and you can put this over a 1. I know that helps a lot of students out. So 2 times 4x would be 8x, and 3 times 1 is 3. Minus 5/8 equals 3/8. And so here we need to work this problem out. I only have one variable here, so I just need to move this over and this over. Now, a lot of people like to remove the fractions here. You can multiply by 24 and remove it all, or you can just go ahead and just treat them as fractions, as numbers. It's a personal preference, but I can see that this is a 24, and if all of these were 24s, it'd be a lot easier, or you can just multiply by 24. And I'll go ahead and show you the multiplying by 24. So if we multiply by 24 here, 24 cancels this, giving you 14, plus 24 divided by 3 gives you 8. So this is 64x now, minus 24 divides by 8 here, giving you a 3. So 3 times 5 would now give you a 15. Bring down your equals. 24 divides by 8 here, giving you a 3. 3 times 3 is 9. And so now I need to get all my numbers over to one side, but I can see that I have a number here and a number here, so I can combine those. And 14 minus 15 is negative 1 equals 9. Add 1 to both sides, and you get 64x equals 10. Divide both sides by 64. And x equals 10 divided by 64, those are both even numbers, so you get 5 divided by 32. Let's look at our last example for today. Here are some special cases. Now, at first glance, they look very similar to all the problems we have, but something unusual happens when we go through the process of solving them. So let's look at 6x minus 8 equals negative 8 plus 6x. If I add 8 to both sides, so that's trying to get the 8's to one side, the numbers to one side. Now I'm going to subtract 6x from both sides. And so if you look, I have 6x minus 6x, negative 8 plus 8, negative 8 plus 8, and 6x minus 6x. So I end up with 0 equals 0. Over here, if I work that problem, let's say I want to move my x's to one side. So I'll move it over, get minus 2x, minus 2x. I want to move my 9 over. So I'm going to subtract 9, and I get negative 9 and 9. 2x to negative 2x gives me 0. Over here I get 2x minus 2x, and 7 minus 9, and that gives me negative 2. So here we have 0 equals 0. Here we have 0 equals negative 2. So sometimes we have a solution, and sometimes we get these two special cases. Well, 0 equals 0 is always true. 0 equals negative 2 is never true. So for this, we say all real numbers. Over here, we would say no solution. Because if you look at these two problems, you're taking something multiplying by 6 and subtracting 8, multiplying by 6 and subtracting 8. You do that to any number, you'll get the same thing on both sides anytime. Over here, you're multiplying by 2 and adding 9, multiplying by 2 and adding 7. You can't add 9 to a number and add 7 to a number and expect them to get the same result. So that's all I have for you today. Happy studying and good luck working on your math problems.